This video is about special right triangles, and you can see these two triangles right in front of us have the same angles. They both have a 30, they both have a 90, they both have a 60. That means that these are going to be similar triangles. Now we call this triangle a 30, 60, 90 triangle, and we name it based on the angles. Now because the triangles are similar, that means the sides are all proportional. But it also tells us that all 30, 60, 90 triangles have to be proportional. So if we have our triangles and we have some sides involved, we know that the corresponding sides, if we simplify them, should be the same fraction for when we match up any two sides. So if I start with the smallest side in this triangle, that's 3, and I match it up with the smallest side in this triangle, that's 7. That ratio is 3 to 7. If I match up the next biggest side in the triangles, now I can put them in order based on the angles. The smallest angle is 30, so the smallest side is 7. The second largest angle is 60, so the second largest side is 7 square root 3. So again, because I put the 3 on top over here, I'm going to start with this small triangle again, and I have 3 square root 3 over 7 square root 3. And when I simplify that, that gives me 3 to 7. Then I have the last two sides, which are the largest sides in the two triangles. They are the hypotenuse. They are both across from the 90. And again, I'm matching up small triangle over big triangle. That is 6 over 14. And that can reduce by simplifying out of 2. And that gives me 3 over 7. So all three of the proportions, the fractions, are the same. So we do see the triangles are similar. Now, we have these 30, 60, 90 triangles, and we know that every single time the sides are going to be in the proportion of 1 to square root of 3 to 2. So let's look at what we mean by that. The smaller sides in the three sides in the smaller triangle, in order from smallest to biggest, this is the smallest number, this is the second largest number, this is the largest number out of the three. And you can use your calculator to decide what the square root of 3 is, change that into a decimal, and you'll see it falls between 1 and 2. So I'm going to do the same thing by lining up these sides. The smallest side is 3. The middle side is 3 square root 3. And the biggest side is 6. I can see that this has a 3, this has a 3, and this is 3 times 2. So to simplify this, I'm going to divide every single one of these numbers by 3. 3 divided by 3 is 1. 3 times square root of 3 divided by 3 is just square root 3. And then 6 divided by 3 is 2. And that's the same as the proportion here. We're going to do the same thing with the larger triangle, just to make sure. We're going to use the smallest side, which is 7. Then the middle side, which is 7 square root 3. And then the largest side, which is 14. Now these three numbers all have a 7, and a 7 times 2. So if I divide by 7, and divide by 7, this becomes a 1, this becomes a square root of 3, and this becomes a 2, which is the same proportion we had before. So every time we have a 30, 60, 90 triangle, the sides are going to be in that proportion. So let's look at an example. So here we have an example problem, and we have a 30, 60, 90 triangle, and we have that the hypotenuse is 8, and we have that x is across from the 30. Now, we know that every 30, 60, 90 triangle has the proportional sides 1 to the square root of 3 to 2. So all I'm going to do is I'm going to use this information for lining up where the sides go. So if we look at this triangle, we have an 8. The 8 is across from an angle. The angle it's across from is the 90. So this 90 is just a guide. It just tells me where I'm supposed to put the 8. The 8 is the 90, 8 is across from the 90, so it has to match up with the largest side. And in the proportion, the largest number is the 2. So then when we move on to the x is across from the 30. So that means from the 30, I will write my x underneath the smallest side. And that is all the information in the framework. And again, we're going to start every problem with this part right here at the top. So now all we have to do is match the sides up based on the angle opposite the sides, which we did. Make a proportion by setting any two fractions equal to each other. So let's go ahead and write, here's one fraction, 1 over x, and that has to be equal to the other fraction, which is 2 over 8. We do not use the square root of 3 because we don't have anything underneath of it. So now we just cross multiply, and we get 2x is equal to 8, and when we get x by itself, we get x is equal to 4. So that is how you're going to do every 30, 60, 90 triangle. So let's try this example here. The difference in this one is that we now have an x and a y. So when we look at this one, we have our framework that we start with. Again, we know it's a 30, 60, 90 triangle. So we start with our 30, 60, 90, the 1, square root of 3, 2. So we're going to start with, we just put our information in. The y right here is across from the 30. That means wherever I find the 30, I'm going to make a fraction with that number underneath of it. Again, that should be the smallest side. The next smallest side is across from the 60. So that is the 8. That's across from the 60. So that's going to go in the middle slot. And then finally we have x, which is across from the 90, which is the largest angle. That will be the largest side. So we put our x here. So even though there are two variables, we do the same thing, which we've done so far. Set any two fractions equal to each other. Always use the one fraction that only has numbers. So when I look at this fraction, it has a y. That doesn't only have numbers. When I look at this fraction, this only has numbers. When I look at the last fraction, this one has an x. It does not always have numbers. So the one that I always want to use is this one that only has numbers. So I'm going to start with that fraction, square root of 3 over 8. Well, let's go ahead and find x first. So to find x first, I'm going to set it equal to the fraction that has the x. So I set that equal to 2 over x. Now I cross multiply. That gives me x times square root of 3. It looks scary, but just write that. That's all it is. Write what it is. X times the square root of 3. Then I have 6 times 2, which is 16. Now I want to get x all the way by itself, and as scary as it may look, we're going to divide by that square root of 3. So when I do that, on the left-hand side, I'm left with just x. On the right-hand side, I'm left with exactly as it is, 16 divided by square root 3. Now, if your teacher requires you to rationalize the denominator, then you're going to need to change the way this looks. If your teacher does not require that, then you stop here. Quick rationalization means I do not have any square roots in the denominator. So I'm going to multiply by a silly version of the number 1. That's just a 1. And when I do that, I get on the top 16 times the square root of 3. And on the bottom, I have the square root of 3 times the square root of 3. That is the square root of 9. The square root of 9, however, is just 3. That way I do not have a square root in the denominator. So that is rationalized now. Now I'm going to do the same thing, but I'm going to find y. So again, I start with the fraction that has only numbers. Square root of 3 over 8 is equal to the fraction with the y, 1 over y. I cross multiply. I get y square root of 3 is equal to 8. I get y by itself by dividing both sides by the square root of 3. And I get y is 8 divided by the square root of 3. If you do not have to rationalize, you may leave it right there. If you do rationalize this, then your answer ends up being 8 square root of 3 over 3. Some of you might recognize a pattern going on there. So that is our 30, 60, 90 triangle. And again, we must memorize this information right here. And that's how we start every single problem with a 30, 60, 90. So we have one other type of special right triangle. That type is this one. This one is a 45, 45, 90 triangle. So for the 45, 45, 90 triangle, we also have a proportion, but that proportion is 1, 1, square root 2. So we're going to do exactly the same thing as we did before, except we're going to use the proportion 1, 1, square root of 2. The two ones there indicate that two sides of the triangle should be equal. those two sides should be the two legs. So the hypotenuse will be different, but the two legs should be exactly the same. So here we go. We've got our example problem. We're going to fill our information in. I'm going to start with the red 4. So here's a 45, and this is the side across from it, 4. So I'm going to put that 4 right here. Could I put that 4 right here? Absolutely yes. I can put the 4 under either one of the 45-degree angles. It doesn't matter. Then I have y. Y is across from another 45, so that's where my y goes. And then finally I have x. X is across from the 90, so it is the hypotenuse. It is the largest side. It will be under the largest number over here. And so here's my setup. So again, we start every problem with 45, 45, 90, 1, 1, square root 2. At this point, we are simply going to do exactly what we did before. We look for the fraction that only has numbers. This is my fraction that only has numbers. So I have 1 over 4 is equal to, and let's find x first, just because we usually find x first, square root of 2 over x. I cross multiply, x times 1 gives me x, 4 square root of 2 gives me 4 square root of 2, and that is my answer. I do the same thing for y. I start with the fraction that has only numbers. 1 over 4 is equal to 1 over y. I cross multiply. 1 times y is y. 4 times 1 is 4. Now, I got 4. Does it make sense? We come back. The two legs should be equal. If this is 4, that means this one should also be 4. So that does make sense. So there we go. We've got our 45, 45, 90 triangles and our 30, 60, 90 triangles. Thank you.